General Motors has been under intense scrutiny in recent years for V8 durability problems that surfaced in many of its full-size trucks and SUVs. Regulators opened a preliminary probe into nearly 877,710 GM vehicles after complaints of sudden engine seizure. And in spring 2025, GM issued a broad recall covering late-model 6.2 V8s, actions that crystallized a very public reliability problem and pushed the company to act. Against that backdrop, enthusiast reporting and industry leaks indicate GM is moving to an all-new V8 architecture for the 2026 Chevrolet Silverado that fundamentally removes the parts of the earlier designs most associated with lifter collapse and related failures. Below, I unpack exactly what went wrong with prior GM V8s, what the new engine reportedly changes, and what that means for owners, fleet buyers, and the aftermarket, with practical, expert-level perspective on durability, maintenance, and trade-offs. How lifter failures became a headline problem. To understand the fix, we must first understand the failure mode. Modern GM V8s in question used hydraulic collapsible pushrod lifters integrated with cylinder deactivation systems, AFM DFM. These lifters let the engine temporarily deactivate cylinders to save fuel. The lifter contains a small mechanical disconnect, a pin retainer, and internal hydraulic tolerances. If the disconnect breaks, or the lifter's internals collapse when they shouldn't, the valve train can lose clearance suddenly. That can bend pushrods, damage valves, or in the worst cases, allow a connecting rod to break free. Catastrophic outcomes that can breach the block or seize the engine. Those failure modes, combined with bearing and crank rod manufacturing issues that investigators have cited, are why regulators and owners became alarmed. Mechanically, collapsible lifters work fine when executed precisely, but they demand very tight manufacturing control and oil system behavior that is tolerant of build variability and real-world service intervals. Where either the hardware or oil control falls short, the parts that enable deactivation become failure initiators. The combination of widespread AFM-DFM lifters and a large owner population exposed the weakest tolerances and made the problem visible very quickly. What GM's new V8 reportedly changes. Public-facing official press material specifically describing every internal change to the new 2026 V8 is sparse in the public domain. But multiple industry reports, enthusiast channels, and supplier-level leaks coalesce around a few consistent moves. 1. Eliminate collapsible lifter deactivation hardware. The clearest single design change reported is removal or major rework of the collapse-style lifter used with cylinder deactivation. Some coverage calls this a no deactivation V8 for Silverado, meaning GM is choosing a simpler solid lifter or a redesigned non-collapsible hydraulic lifter to avoid the failure mode entirely. That's the fastest, most direct path to remove collapsible lifter risk. Number 2. New small block architecture. Reporting points to a next-generation small block V8, a Gen 6 style successor in enthusiast shorthand, with redesigned internals, revised lifter geometry, updated valve train clearances, strengthened connecting rod crank interfaces, and improved oil control passages intended to mitigate bearing and oil starvation concerns. These are the sort of systemic changes necessary to shift reliability upward, rather than papering over a single symptom. 3. Manufacturing and inspection tightening. After the NHTSA probe and recall activity, GM has publicly and privately emphasized expanded dealer inspections, revised oil viscosity guidance, and at least targeted changes in assembly QA for rotating assembly tolerances. Those process changes are as important as the parts swaps because many engine failures relate to marginal manufacturing tolerances that only become critical under certain oil temperature, viscosity, service conditions. Engineering trade-offs. Why cylinder deactivation matters and what you lose gain. Removing deactivation hardware isn't just a reliability decision, it's a performance and efficiency trade-off. Fuel economy versus durability. Cylinder deactivation improves part load fuel economy by shutting off fuel and valve lift for some cylinders when cruising. Removing it simplifies the valve train and reduces failure points, but at the cost of some EPA test cycle fuel economy. Manufacturers often balance durability against incremental MPG gains. GM's move suggests durability and customer trust are higher priority in this product cycle. NVH and drivability. Modern deactivation systems require calibration to smooth transitions. A non-deactivation V8 can be tuned for consistent NVH and throttle response without having to mask cylinder on, cylinder off transitions. Some drivers prefer the simplicity, others miss the subtle economy gains. Aftermarket and performance communities. Removing collapsible lifters simplifies aftermarket valve train swaps, solid lifters, performance cams, and reduces need for DFM deletes that many owners have used to prevent failures. For shops and tuners, a robust, solid lifter V8 is friendlier to modification. Enthusiast channels have advocated for deletes and retrofits for years. GM's engineering change effectively gives that population what they've been asking for, factory-backed. What experts and seasoned technicians recommend now. From a practical shop floor point of view, here's what engine and truck experts say owners should expect and do. 1. Warranty vigilance and documentation. Owners should keep up all service records and insist on dealer inspections if any unusual noise or oil pressure behavior occurs. The NATSA probe and recall activity mean dealers and GM have pathways for inspections and, in many cases, repairs or replacements under warranty. Document everything. 2. Oil control and maintenance. Because many lifter and bearing issues interact with oil viscosity and contamination, stick to recommended oil grades and intervals, or shorter if you tow heavy use. Experts warn against long drain intervals, cheap oil filters, or incorrect viscosity that can exacerbate marginal bearing tolerances. Number 3. Consider DFM AFM delete options cautiously. The aftermarket offers deletion kits that lock deactivation solenoids or replace collapsible lifters, and many owners have used those to avoid failures. But such options can affect emissions compliance and warranty coverage. If you're under warranty, coordinate with your dealer before modifying. Post-2026 designs may remove the need for deletes altogether. 4. Buyer wait decision for 2024 to 2025 used new inventory. If you're cross-shopping older Silverados, the honest expert view is buys of earlier model years, 2019 to 2024, should be made with eyes open. Ask for detailed inspection reports, ownership history, and CV engine inspection results. For buyers who prioritize absolute peace of mind, waiting for the 2026 models with the redesigned V8 or verified factory retrofit repair programs is a reasonable strategy. Regulators' involvement means some recall remedies and extended coverage could be forthcoming. Broader implications for GM and the truck market. This is more than a part swap. For GM, the reputational hit from engine failures and dealer repair disruptions translates to lost buyer confidence in a core product. Silverado and large SUVs are volume sellers. A clean, reliable V8 addresses the technical problem and sends a marketing message. GM is doubling down on durability. But there are economic consequences. A simpler, non-deactivation V8 might slightly reduce EPA fuel numbers, shifting the competitive calculus with Ford and Stellantis, who find other ways to balance economy and emissions. For fleet buyers and commercial operators, the change could be decisive. Fleets value predictable uptime and total cost of ownership more than a few MPGs. A V8 with fewer failure modes and a clearer service paradigm, fewer surprise shop visits, becomes more attractive even if it's marginally thirstier on paper. For GM's large commercial sales channel, that's strategically important. Final verdict. Practical expert takeaways. Mechanically sensible fix. Removing the collapsible lifter deactivation hardware is the most straightforward engineering way to remove the single biggest failure mode. If GM's new V8 uses solid or redesigned lifters and tightens rotating assembly tolerances, that's a meaningful improvement. Process matters as much as parts. The NATSA probe and recall showed some failures were systemic and linked to manufacturing inspection tolerances. Improvements in QA, assembly, and dealer diagnostic workflows are equally important to the hardware changes. Owners should be proactive, maintain oil and service intervals, keep records, and ask dealers about inspections and active service bulletins. If buying used, insist on documented engine health checks. Longer term, expect better aftermarket compatibility. A simpler valve train is easier and cheaper to live with for fleet users and enthusiasts. That will likely reduce repair costs and aftermarket complexity.